Assalamualaikum and good evening to Madam Zubainun. My name is Nushasha Idina binti Mama Azad. Student ID 2024289874 will now continue our group's next presentation, Experiment 5, Frictional Force. The objective of this experiment is to determine the coefficient of static friction of different surfaces. Next, let me introduce this experiment. Frictional force is the force that resists an object's motion on a surface, and it occurs when two surfaces are in contact and slide against each other. Friction are mainly divided into two types, static and kinetic friction. Static friction is a friction that acts on an object at rest in order to move the static object. Kinetic friction, on the other hand, is the friction that acts on a moving object. But in this experiment, frictional force between wooden block and rubber surface on a horizontal inclined plane is measured. Thus, by plotting the data, static friction can be obtained. Here is the list of apparatus used in this experiment. First, wooden block, that is rubber covered on one side, 50 gram masses, 10 Newton spring scale, string and tabletop. Next is the procedure or sequence of this experiment. Firstly, the mass of wooden block is measured and recorded as m. Secondly, the apparatus was set up as shown in figure 5.2. Third, the tabletop was made sure stable and horizontal to the ground. Fourth, the spring scale and the wooden block was attached with a string. It is then placed horizontally on the tabletop. The rubber side of the block was made sure to face downward. Fifth, M equals to 50 gram mass was placed on the wooden block. 6. The spring was pulled slowly, and once the block started to move, the spring scale reading was recorded. The value of static friction force was recorded and tabulated in table 5.1. 7. Step 4 until 5 was repeated. 8. Another 50 gram mass was added on the wooden block, and step 5 to 6 was repeated. The step was repeated until a total of m equals to 500 gram mass is on the wooden block. Lastly, step 1 until 8 was repeated, with the rubber side of the block being made sure to face upward.
Now let's take a look at the results. This is the data and the result that we collected from the experiment. Mass of wooden block with rubber surface M is equal to 81.92 plus minus 0.01 gram. Moving on, this is the analysis of the experiment. Number 1. Draw and label the free body diagram of the wooden block. The forces acting on the wooden block is upwards normal force, downwards gravitational force, applied force is to the right, frictional force is the opposing motion. In the next part of the analysis, we have to plot graph of static friction force against normal force for the rubber surface and non-rubber surface. As you can see, in the center, we have the graph of static friction force against normal force for the rubber surface. And this is the graph of static friction force against normal force for non-rubber surface. On to the following section of the analysis. Use the gradients obtained from the graph to calculate the coefficient of static friction for each surfaces. As you can see, from our calculations, we obtained a result which is 1.26 for the coefficient of static friction for a rubber surface and 1.18 of the coefficient of static friction for non-rubber surface. Now, last but not least, compare and discuss the coefficient of static friction obtained. The coefficient of the static friction obtained for wooden block with a rubber surface towards the floor is 1.26, which is greater than the wooden block with non-rubber surface towards the floor, which is 1.18. A high coefficient of friction means that more frictional force is present relative to normal force. Therefore, this means that the wooden block without rubber surface needs less force to move the wooden block compared to the wooden block with rubber surface.
My name is Ain Zulaika binti Aidin, student ID 2024236834. So I'm going to do the questions part. So number one, how can anti-lock brakes stop a car in shorter distance than regular brakes? Anti-lock brakes regulates brake pressure and sensors are used to detect wheel motion and does not allow wheels to lose track. Hence, the car will stop at a shorter distance and potential accident can be prevented. So next, question number two. From your experiment, which material has the highest coefficient of static force? Does the does this agree with your hypothesis? What do you think determines the coefficient of static friction? Okay, so the answer is the material that has the highest coefficient of static friction is the rubber surface. Yes, this agrees with our hypothesis. If we add more mass to the wooden block and slide it across a rubbery surface, then the force of friction will increase because when the object gains more masses, more force is needed to pull the object, causing the friction force that acting on the object also increasing. So, the last question is once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. So, the answer once the mass begins to slide, the rubber surface which facing the floor is undergoes stop and go motion because of the coefficient of static friction force is the highest. Meanwhile, the non-rubber surface which facing the floor moves smoothly as the coefficient of static friction force is the lowest. So, in conclusion, by examining the relationship between static friction force and normal force, the experiment was able to calculate the coefficient of static friction for various surfaces. The findings showed that the rough rubber surface had a larger coefficient of static friction than the smooth wooden surface, indicating significant differences between the two surfaces. This result highlights how material characteristics affect frictional interactions. The forces needed to overcome static friction were clearly shown by the proportionate relationship between applied force and the start of motion that was seen. In addition to providing students with theoretical and practical knowledge relevant to scientific and engineering contexts, these findings enhance their comprehension of frictional forces. That's all from us. Thank you.